Here are the answers for the 212 review preview. So the first section says to simplify each algebra expression below, if possible. If not possible to simplify the expression, explain why not. So in the first one, we can simplify. We have several y's that can go together, and then the y squared and the 5 actually stay by themselves. So we can actually just write down it's y squared plus 5 plus 1 is 6y plus 5. For the next one, we have a 3y squared, no other 3y squareds. 2xy, no other xy's, no other constants, no other x's, no other y's, and no other 2x squares. So the answer is it's not possible. So you needed to write not possible because there's no like terms. So it's already simplified. A couple people rewrote the original problem, which is incorrect because the instructions clearly stated to explain why it wasn't possible. So the next one is 3xy, there's none of those, but 5x, there's an x, and there's a 2 and a 4. So I can say I have 6x plus 3xy plus 3y plus 6. For the next problem, it says if tiles had dimensions shown at right, what's the name of the tile collection below? That is, what's the total area of all the pieces? So in doing this, I kind of like to mark them as I go. So I'm going to start with all the x squareds. So I have 1, 2, 3, 4, 5, 6x squared. So that's what I'm going to start with, 6x squared. Plus, then I'm going to look at my x's. I have 1, 2, 3, 4 x's. Plus, then let's do the xy's. There's 1, 2, 3 xy's. Y squared, there's only 1. And then there are 1, 2, 3, 4, 5, 6 y's. So that would be my most simplified expression. Problem number 19, I'm evaluating my expressions. So I'm plugging in a number for them. So for the first one, I'm replacing -1. So I have -4 times -1 plus 3. Negative times a negative is a positive. So 4 plus 3, final answer is 7. For B, I'm replacing k with 4 minus a -10. So I have to change subtraction into addition. So it becomes 4 plus 10, which is 14. I can follow my keep, change rule. For C, I'm going to do 7 squared plus 5 squared. So I get 49 plus 25, which ends up being 74. The next problem says solve the following problems. So in these ones, I thought that the easiest way to do them was to write a proportion for the first one. It says I have 135 candies, 27 are blue. At this rate, how many candies would be how many blue candies would be in a pile of 1,000. So I can say, all right, I have 27 out of 135 equals x out of 1,000. So I cross multiplied. I got 135x equals 27,000 divided by 135. X ended up equaling 200 blue. Then for B, it says 10 calculators cost $449.50. How much would 100 cost? 1,000, 500. So if 10 costs $149.50, I can just multiply by 10 to get 100's cost. So 100, I know costs 1,495. So that's how much I have for 100. So then to get 1,000, I could just multiply by 10 again, which ended up equaling for 1,000, it cost me $14,950 for 1,000. The last one's 500, so I can just take the one for 100 and multiply it by 5. So I just took 1,495 times 5, and got that it equals 7,475 for 500. So I needed to have all three answers. Okay. Problem number 21, it looks like, says name the coordinates of points A, B, C, D in XY form for part A. And then for part B, we're going to graph them. So for A, I know that A is at -4, +3. So I'd write my coordinate -4, +3. For B, B is at 2, +1. C is at -2, 0. This is a common misconception. You always go right or left first. So C would be -2 and then 0. A lot of us flipped it over. And then D is at -3, -3. Same thing for when graphing. I think a lot of students, when they graphed it, they kind of flipped it when it was at 0. So for these ones, it says plot the points as well as label them. So we want to put the letters on it. So 5, +5, +2 is right here. So this is E. -3, -1 is right here. This is F. And then G was probably the most missed one. It was 0, -4. That means I don't go right or left at all. I just go down to -4. So this is where G was. And then H was at 2, -3. It's right there, which is H.